All right, welcome. My name is Corey Canfield. I'm an aspiring software developer. I'm working on a project called Forsaken Forest Asylum. I've been tasked with highlighting 3 artifacts of this project that needs enhancement. And so the first area of enhancement that I'm looking at is level generation. My project typically had a static level throughout. And what I want to do is I want to allow users to use any paint-based program to design their own levels and import them into the game and have the game translate that paint-driven file into a game world that they can play in. And so this is going to be accomplished using a technique called bitmapping, which bitmapping is associating a color to a particular game object and then iterating over that texture of colors and instantiating game objects in the proper location. So if we look at the game here that's running, I have my little guy that's running around, and up here in the top right is the map that was generated with this tech. And so the red area is the path. The white areas are doors that cannot be traversed through. The horizontal blue line is the horizontal fence here, and then the vertical green is the vertical fence, and then the yellow is obviously the dirt. So for all intents and purposes, the script is working. However, I've identified some limitations within the code that I think need to be highlighted and improved upon. So let's dig into that. We'll take a look at the code, and we'll see what we can come up with here. So the level generator is written entirely in one script here. It's pretty small. There's like 60 lines of code here or so. And the way it works is it gets a reference to a texture. The texture is the object that the player would create. So I'm using a program up here called Sprite, and this map that I created is 16 by 16 pixels. And just to show you that it is working, let's go ahead and edit this for a second. We'll just erase some tiles. We'll just fill them in with some paths here. And so now we should have a pathway, basically. Make sure I save it in the right location. Overwrite it. And so I should be able to run the project, and it should iterate based off of that now. So as you can see, we now have pathways in places where fences and tiles used to be. Created entirely from a paint program, which is pretty cool. I could see some players getting pretty unique with their level design if you gave them enough options. So, all right, let's dive into the code. All right, so we got about 60 lines here. We'll step through it and we'll talk about each area. So, again, the game map is a texture that the player creates. We covered that. The pixel map is the mapping of colors to game objects. So that's an array, and it's public, so it's serializable in the inspector. So as I'm building my game, I can pick the colors I want the player that the player's going to be painting, and how it's going to be referenced to, or what game object it's going to be referenced to. And so this can be visualized here on the right. So I have a basic yellow, a 255, a 255, 0, 0 yellow, and that's the dirt tile that you were seeing in the demo there. And then you got your white, which is your fence, your blue, which is your fence middle, and so these are all custom game objects that I've built. And we'll take a look at one of those too, just so we can kind of get an idea. So this is a sprite that I created, and it's running some other features here, sprite renderer, so it can be visually seen, and then it's got a tile script behind it, which is more or less just properties about the tile and what it's going to do. All right. Empty prefab. I don't even think empty prefab is being used, so this might be a remove to do remove. So I think this is an unused feature. So we'll queue that up for removal here. All right. So the first thing we do is when the script loads, it's going to generate the level. And so what it's going to do is it's going to iterate over that texture that the player created, because one, we don't know how big it is. They could have created a 128 by 128 texture. They could have created a 64 by 64 texture. We have no idea. So we have to look at the width of that texture and the height of that texture, and we have to do a nested loop. And so our nested loop iterates over the x and then over the y's. And as it does that, it's calling a generate tile function. And so this generate tile function uses, Unity has a nice feature within the color API where you can get a particular pixel at an XY coordinate. So what we're doing is, since we're iterating over our X and our Y up here, we're providing those as parameters for our generate tile. And when we do that, we're able to acquire the color of the pixel that we want to evaluate. So if we're going out and we're pulling in a red pixel, we can then evaluate the pixel color here. And so the first check we're doing is the pixel an alpha? Is it transparent? Because if it's transparent, we don't want to do anything. A transparent pixel has no color. It shouldn't associate with anything. It could associate with something, but we're choosing to not associate with anything. Actually, we're choosing to instantiate an empty prefab, so maybe we don't want to remove this up here. All right. And then once we have our pixel map list, then we're going to, so every time we call the generate tile, we're going to iterate over our mapping of colors and game objects with the pixel color that we've acquired. And then we compare the pixel color that we acquired to the pixel color that is associated in our mapping. And if they match, then we're going to instantiate the game object associated with it. So that sounds really confusing, but it's really simple. So the idea is that we get the color here from the XY coordinate. And then this for each loop comes out to our, sorry, here, I got to get back to the game manager. Okay, so it comes out to this pixel mapping array. And it says, hey, does my color match one of these colors? And if it does, then it's going to instantiate the prefab that's associated with that element of that array. And so this color mapping with prefab is a custom data class. Let me open that up so we can look at that. It's very simple, but just a basic class that has two parameters, or two components here. One is the color and the prefab. That's it. So we needed to use a custom data structure here because the array can only have one element per indice, and we needed to basically match these together or marry them together. So we iterate through all those colors. We instantiate all our prefabs at a given x, y that we pulled in with our x and y parameters that we applied to the generate tile. So this color to hex function is a custom function, and basically what this is doing is it's taking the color that we have, converting it to a hex value, and then comparing. However, I think this is an area of improvement that we need to look at because it doesn't seem to be working quite that well. I can't have two reds that are nearly similar. If I do, I'm not getting the right prefab. And to highlight this, we can just, here's a red, and let's say we drop the value down. Here, let's do this. We'll make it kind of a pinkish orange, right? And then we'll paint this in. And so in theory, this line shouldn't get iterated over at all. Well, it'll get iterated over, but there'll be no game object associated with it because it's a color that's not defined. So if we go and run our game now, chances are it'll still be a path. Yeah, so it's still a path because it still thinks it's close enough to the red in that comparison that it thinks it's still a path. And that's a problem because if you have a lot of game objects, you need a lot of colors to support each type of game object, at least with this model. So that's a real problem. And so with this map that I created, I tried to use distinctly different colors, and then I was able to get it to work. So we have an issue there. So that's basically that's the basic portion of the code that we have. And if we kind of go over checklist here. So I'm going to do this video in 3 parts. This is part 1 for the level generation, and then I'm going to do 2 separate videos and then combine them. But if we go over this checklist, okay, so we've gone over the level generator and how it works, the tech behind it, and we've talked about bitmapping and colors and quite a few different areas here. So we have a code review checklist here, and I've gone through it on my own time, and I've generated a to-do list on how I believe we can improve this piece of code or enhancement for this artifact. So the first area, improve clarity around pixel color, pixel map naming conventions. So this area of code is very confusing. You have pixel map, pixel mapping, you have pixel color, pixel map dot color. It's unclear how each of these elements interacts and really their unique role in the process of processing a pixel color. So we need improved clarity around that. That's going to involve renaming these variables and coming up with a scheme that makes sense. Research color to hex conversion or improved color comparison method. The color to hex method here doesn't work right. We demoed it before where we drew in a line of orange and it rendered the same tiles as pure red. So we're not comparing our colors correctly, so that needs work. And that's what I'm not sure if Unity has a built-in method or not, but we're going to do some research there. And I know that, we're using a color, but there's also a color 32 object. Maybe we need to be using a color 32 object. That'll come as I go through the research on that piece of it. Clarity around for each color map. This is the same thing I'm speaking about now. Validate that we have a texture map. So we get a texture map from the player, but we have no idea if it's actually, if we have it or not. If we don't have a texture map from the player, then we need to load a default map. So when this script loads, it's jumping right in and trying to generate based off of a texture map. And we need to do some error handling around that. Potentially a Boolean flag. Do we have a custom map, or do you want to load a custom map? Something along those lines will certainly help a lot here. Okay, further research around try-catch with texture map loading. Yep, we could use a try-catch here as well, or a Boolean, or however we want to do it, but we need improvements here around texture map loading. Validate the grid size against the texture map size. So one area that I didn't cover, because it's kind of out of scope, but it's still related, is the game manager. The game manager holds a XY grid position, and it holds a 2-dimensional array for our grid. So if our game manager grid is not the same size as our texture map 2D, then there's going to be a mismatch here. Say we're loading in a 16 by 16 texture map, and our grid is 10 by 10. We're going to have portions of the map from the texture map it's going to populate those tiles, but they'll be unreachable. Or if you have the opposite, you may be able to travel to places where there is no tile. And if you use functions in the game that say, hey, give me the tile you're currently on, the game's going to crash because you're going to get bounding array errors because there's a mismatch between what the player and the game loaded for the texture map and what the game manager knows about. So we need to work on that. And then finally, the third area, which is something I hope I have time to do, is to create like a custom Windows Forms app that is specific, that I just want to bundle basically a Forms app into my game. So it's an external tool that I'll give to the player, and it's just going to be a simple drawing app. And the only thing they're going to be able to do is resize the canvas, and then they're going to be able to pick from a predetermined set of colors, which is basically going to be my input validation. And those colors are going to relate directly to the game objects. So they'll use that specific drawing application to draw their maps. And then we can either save them locally or we can save them to the cloud, which will be covered in a different enhancement. But I'm hoping I really get time to do that because I think it'll be very valuable. So that covers it for the first enhancement. We're going to dive into the second enhancement here in a minute. Thank you so much. All right, so the second feature that we're going to be enhancing here is tile manipulation. This falls under kind of an algorithm and data structure enhancement. And the way it works is through bitmasking. And so this feature wasn't implemented in my project previously. I've actually done it this week, and we're still going to be looking at how to improve it because I feel like there are some shortcomings with some of it. But if you look at the GIF here, this is a GIF of Stardew Valley, and you have an open field of dirt, essentially. And it doesn't matter where the player digs, the tiles around it conform to make kind of a meshed graphic. And so this was really appealing to me because when you're playing the game, it happens so seamlessly, and you don't really realize how it's working until you try to implement it. And it actually was, I tried implementing it in a bunch of different ways and failed quite miserably until I learned about bitmasking. And bitmasking turns this very potentially complex problem into a very simple one. So let me explain what bitmasking is, and then we'll show you the implementation that I did. And we'll go from there. All right. So bitmasking is basically having a set of tiles. I also have an article here I'm going to bring up too. So bitmasking on the right here is the set of tiles in my game. And if you were to turn on the grid, show grid, and you were to number these tiles, so this would be 0, 1, 2, 3, and you kept going down, this last tile would be 15. And this is important because when we start to look at our grid and our player position, what happens is when a player, and I'm switching over here on the right here, when the player is evaluating a tile, you can get a unique value based on the cardinal directions around them if you just use some simple math. So looking at this screenshot here where it says step 2 bitmask, if you're evaluating the center tile, what you need to do is you need to assign a value to north, east, south, and west, and you'll notice that they double in size as they go around. And you can expand this to 8 directions, but it's a little more complex, but it's the same works. And so what happens is if a tile is, if there's no tiles around the evaluated tile is always going to be the center tile. It would be a value of 0, and so you would paint the 0 tile over here that I've highlighted. Say you had a tile above you that was also dirt, then you would have a value of 1 because that tile represents 1, and then you're putting a value in your selected tile, and then you would actually paint the 1 value. Remember, the tile you're evaluating is where you're painting. So if you look at this graphic over here, and then you compare it to the picture over here, that tile would fit perfectly if there was two U-shaped tiles here, a U-shape on the bottom, a U-shape on the top. And then you can just continue this because basically what you're doing is you're using binary to assign a unique value to all 15 of your tiles. And so at any given point, you can evaluate all 4 cardinal directions and get a unique value depending on what tiles are around you. And then you can change the tile the evaluated tile. And then what you have to do is you have to iterate over all your tiles and then update the values of those tiles based off of what their neighbors are, basically. So let's look at the implementation. All right, so there's 2 classes. There's a data class called cardinal direction. The cardinal direction class has 3 attributes. It's got a directional value, which is the 1, 2, 4, 8 that we're referring to. We have a directional character, which is nothing more than a single character that says N, E, S, or W. And then we have a direction vector, which is going to be, in Unity, it's up, vector 2 dot up, vector 2 dot right, vector 2 dot down, or vector 2 dot left. And then we have a constructor for that. All right, so in the bitmasker class, which is how we're doing this, we have 2 functions. We have an evaluate all tiles, and we have an evaluate tiles function. And so this evaluate tile function just takes in a single position, evaluates your north and your south, just as we were showing here. It basically runs through and it says, hey, give me the unique value. it basically says return the unique integer value of my tile. What's around me, basically. And once you have that integer value, then you can go out to your sprite sheet and you can say, hey, I need tile 15, or I need tile 12, or I need tile 3, based off of what I have around me. And so after you evaluate a single tile, then you need to go through and evaluate all your tiles, because if you change a center tile, the corresponding tiles around it will change. So to highlight that, we'll just run our game. I didn't update the map from part 1, but it's okay. So make it a little bit bigger here. So if we come up here, actually we'll go over here because it's a little bit bigger. And so say we dig once, right? We get a circle because there was no tile to the north, there's no tile to the east, there's no tile to the west or south or west. As soon as we put a tile, say to the west, it changes it. So this circle tile turned into a, I'm looking for the number, so 3, it turned into an 8. This 0 turned into an 8. And then this one, which could have been a 0 if it didn't have any neighbors, turned into a 2. And you can put down a 0. And then those will get unique values. That will get, whatever the value is for an upside down U, and whatever the value is for a regular U, which is a 1. And then you can expand it. And as you dig, it's constantly evaluating your current tile and then refreshing all the tiles, which is, it's really pretty cool how it does that. So in a situation like this, it's going to meld all of them together. Situation like that, it melds them together. All right. So keep this pretty short since we only have 2 functions here. But basically, we add in our 4 cardinal directions. Now, I made this class really simple because this data structure, because I wanted it to be used for 8 directions if I wanted to expand it in the future. So when this loads up, it's like, hey, add in my 4 directions, and then we're going to evaluate those 4 directions. If you wanted to instantiate this with 8 directions, go ahead. It would be more numbers, and you would need a much larger sprite sheet. You would need, I think it's 256 sprites for an 8 direction, whereas a 4 direction is 15 sprites. So granted, they're not all unique. I think it's 48 or 47, I'd have to do the math again, unique sprites in an 8 direction map. But basically, we add the directions we want to evaluate. We iterate over each of our directions. And then we do a simple try catch here. Is there a tile? We're doing that in case we get a weird like array issue where it's like, hey, there's no tile here, or the tile is not of the tile type that you want. So we're trying to catch some of those errors before they happen. And then if the tile is a soil type, then we grab a running total, which is basically evaluate your 4 directions, get me that number, and then return the running total. And then down here, we evaluate all our tiles. So this is going through every game object in the scene that is a tile. It iterates over them. Again, it uses the same evaluate tile function that's up here, gets that total, evaluates it, and then it basically calls this till soil function, which just is nothing more than setting the sprite based off of the integer value that the function's returning. So it's very simple. All right, so if we dig into a to-do list for this, again, I went through that same checklist on my own time to kind of keep these videos as small as possible. And the one issue that this code lacks is commenting. There's no comments. I'm having to explain it all, but if someone was to come in here, they would really have to dig into each of these functions. And I mean, this function's quite long, and really kind of try to understand what's going on. The other thing that's going on here is we're never using this character value in cardinal direction. So I'm proposing that we, 1, comment our code, 2, remove this character direction because it's not used. It's never used. I thought I would need it when I was building the data structure, maybe for some other type of evaluation or something, but I'm not using it, and I don't think I'm going to be needing it. So I think that needs to come out. There's some inconsistencies in naming. So in the evaluate tile function, we're using an integer called running total, which I like a lot better, versus in evaluate tile, we're using an integer called just total. So I think we can probably standardize that a little bit. Overall, the loops and try-catch statements and the if statements all look good. The structure is fine. The indentation's fine. The other variable names seem pretty good. I mean, eval position is pretty self-explanatory. Direction vector, that makes sense to me. We're using an enumeration for our soil type that reads very nicely. Tile type.soil. I know exactly what that is. I'm trying to put myself in the seat of a developer that's never looked at this code and trying to just evaluate it from, 1,000-foot view. And I think there could be some improvements here for geo. Geo is a common naming convention in Unity where people use it to reference a game object, but I think we could do better. So evaluate all tiles, rename geo variable and geo list, might as well. Tile 2, that's a poorly named variable. Rename tile 2 variable. We're calling our evaluate tile, so it looks almost like some recursion there. And till soil, that's fine. So I think that's it. This. I feel like this code's pretty efficient. It feels pretty good. There's just some minor tweaks here, cleaning up the code a little bit, adding some comments, and I think it's gonna be pretty good. But it functions very well. And without this, to go back to this just briefly, I've worked on this before I started this evaluation of my code. The way I was doing this was I had a sprite that looked like 15 here, which was there was no borders. And what I would do is I would replace the dirt sprite with that. However, it gave it a very blocky and chunky feel to the game, where this feels very natural. It feels like the player gets to shape the land, and it makes it a little more personable instead of having these like really hard edges. It just feels, I know it doesn't feel right. With this, it feels like it gives you more immersion, I guess, in the game, which is it's really good when you're building a game. You want immersion. You want the player to be invested in what they're doing and be able to customize what they're doing, and just having a really blocky texture. All right, so for this third artifact, I wanted to revisit the level generation portion that we covered in the first artifact, and I wanted to provide the ability for the user to create levels, which is what we covered in the first artifact, but I also wanted them to be able to upload them and share them. So I wanted to utilize MongoDB as a backend and implementing some simple CRUD functions and allowing them to create their map, send it up to the cloud, and then having other users be able to have like a menu that they can select other maps and try those maps as they're submitted. So let's show you what I have so far, and we'll go from there. So we got the basic game here that you've seen before. We run the game, and visually there's no change here. However, we have some output in the console, and so it's indicating that we're connecting to our Mongo database. It's fetching the collection list that we have. We only have one collection. It's called maps. So it's returning that collection name. And then what we're doing is we're converting this test map that we can open that up. This test map that we were reviewing in Artifact 1, it's converting that to a base 64 encoded string. And it's doing that because that's a convenient way to upload it to MongoDB. So if we go over and we look at the MongoDB interface, let me pull that over, we'll see, I added some timestamps here too. So 10:13 a.m., which corresponds to the time now. We've got our test map going up. We've got our image base 64 encoded image data going up, and we have just a generic timestamp. And if we grab this image data, this base 64 image data, I found this online tool where you can take a base64 string, paste it in, and you can generate an image based off of it. So that looks very similar to what we had before. I have a feeling the website probably scales it up. So that's why we're seeing some blurriness, or maybe there's some bilinear effects happening here. But regardless, you can see the white pixels here for the doors, the lack of a white pixel here. You can see the red for the pathing, the yellow, the green. So for all intents and purposes, I believe this is going to work great. And storing it in a binary, a base64 encoded string, hardly uses any space. I mean, this whole record is incredibly small, which is going to be great for our MongoDB. It's going to be fast. It's going to be easy to retrieve. And our database is going to be able to hold, quite a bit. So, I mean, we have 2 maps stored here, and our collection size is 714 bytes, which is incredibly small. So let's look at the code, and I'll show you what I have so far. So, again, with this project as a whole, I've kind of put the cart before the horse. When I was doing my enhancement plan, none of these features were here. So I've quickly coded in some basic functions to kind of get these tools up and running, and give me an idea of what it's going to take to interact with Mongo, push information up to Mongo, pull information back down to Mongo, and kind of start working through that whole process. So first, I've got some constants up here. And so I hemmed and hawed a lot about the URI, because the URI actually has the collection name in it, it's got the username in it, and the password in it. And so I've limited that user within the Mongo security interface, so this user can only read and upload. And there was a pretty specific reason for that, and I don't really want to get into creating user accounts and capturing user information with an email address and going through that whole creating a profile, an authorization profile for each user that's going to use the game, especially if the game is sold overseas, because then you're starting to deal with like personal information and GDPR, and it gets, that's a deep rabbit hole to go through. So I opted to kind of take the 90s approach, which is what I call kind of an open FTP that's basically a repository that people can send stuff to, but they can't pull it down or delete it. Or I'm sorry, they can pull it down, but they can't delete it. So it's kind of, it goes up and it stays up. And if the database is growing exponentially at too fast of a rate, then what I can do is I can write a backend function that just blows the database up every, say 3 days, just clear the whole database out. And if users want to put the maps back up, they can. It's not a big deal. It's not like I'm charging them for this. It's just kind of a convenient service to share maps and things like that. All right, so we have our connection string that gets us to MongoDB. We've got our database name. We've got our collection, which is where our maps are stored. And then we have up here, we've also imported our driver, our BSON driver, and those are the ways that we can use these tools to connect into the database. We set up a Mongo client, and we set up the database here. And so then what I did was I created a few functions here. So a get collections function. So this is just going to return a list of strings, which are the collection names that it returns. It should only ever return one right now because there's only one, but it's kind of a helpful function to say, hey, what's out there? Then we have a basic insert record function, which is taking a connection, and it is grabbing a local file on the disk. It's converting that file to a base64 image, and then it's basically pushing up a BSON document. A BSON document is what we're looking at when we open up MongoDB. So this is basically for the lack of a better word, it's just an XML document essentially. It's key value pairs on what we're representing here as a data record. So. And so within that, we've got a couple strings to represent our map name, which is the title of whatever we want to store. Our map name that we're uploading is called test map. We have our image data, and then we send up the image data representation string that we've converted up here. And then we've got a couple timestamps. and then we just send that up as an insert. We've got a connection method here. The connection method does do some, it does return a true or false based off of, are we connected or are we not connected? And it's doing this by running this async command that's basically going out and pinging the Mongo server and saying, hey, are you alive? And if that comes back as a 0, then, you know, we're not connected. So this is going to be useful when we actually start to build out our files that are actually doing all the connection stuff, because we can do error checking whether we're connected or not, and kind of avoid those like race conditions. And then this is a different version of this was kind of the final version of the Git collections. So this was the initial one that I wrote, and then this is one that I was testing. I started testing an async version of it, and I think this is the one I'll end up using. So it's very crude, but we're getting there. So, you know, we've got some basic connectivity, and it works good. So on my to-do list here, so I've run through the checklist of improvements, and on my own time to keep the videos here at a minimum. And this is what I've come up with. And I've got quite a bit of work to do here. So I've got to finish the CRUD functions. I want to implement all 4, you know, create, read, update, delete at a minimum. Even though I don't think the delete will be used, it'll be good to have. And if I continue to keep my connection profile modular, I might be able to add in like an admin portion where I can log in and maybe I can clear the database or remove maps or data points myself as an administrator. So I think it'll be important to have that. So we're gonna finish our CRUD functions because we've only got an insert in here, and we've got we actually don't even have a read in here, but we'll get to that. Research synchronous versus asynchronous, and I'm not sure which way I should go with this. So typically asynchronous would put everything kind of on its own thread. It's going to be non-blocking on the UI, but it depends on how I approach the development of the interface. Like if the interface for uploading the map is in the game, then synchronous or asynchronous, it probably won't matter, because you're going to reference a file outside of the game, and it's already going to be completed, and then you can just send it up, and it's going to be so small that it's going to take no time to do it. So I'm not sure if I even need to worry about asynchronous or not. And it's not like we're waiting for some authentication to come back and say, hey, yes, you can do this. And I think that's really where asynchronous would benefit over synchronous. But I'm going to do a little more research on that and really kind of define where my application fits in, one side or the other. Improved error handling around the CRUD implementation. So, this insert, if we use this as an example for all of our CRUD methods, there's no error handling here. So we definitely need to work on that. Try catch statements on the inserts, on the reads, the deletes, the updates, all that. And handle those things. Like, if we're failing to connect on a create statement, then maybe we should have a number of retries. How many times do we retry our database connection before we give up, and kind of work through those types of issues, because that's going to be important. Because if a person's trying to create a map, they want to create the map. They've already created the map. Now they want to push it to the online cloud, and they shouldn't have to retry. Like, let the software do that a certain amount of times. I need to work on a helper function to improve referencing images in the file system. So this is atrocious. Like, this should be a lot better. One, it needs to be modular, so we can't be hard coding test.png wherever. So we need to be able to have a file selector that references these images, and a way that we can load them in to a byte array and then convert that to a base 64 string. So we're going to have to work on some type of utility class for that. I kind of already covered this. Do we need to salt or encrypt our DB credentials? That's kind of a question for the professor here. So, I don't think I do, based off of my previous explanation. So, but if you have input on that, I'd love to hear it. comment code with summary blocks. So since this file is going to be modular and accessed other places, I want summary blocks throughout. So if someone else got their hands on this code and they want to connect to a MongoDB and they want to use the CRUD functions, it's clear what the usage is of those functions. So a summary block is nothing other than 3 lines, explain what the function does. And if this function had parameters, then you would provide the parameters here and explain what the parameters are for. And when someone's using IntelliSense, it will help them construct the call to the method. So move constants to a separate file. So these constants could be in a separate file entirely. I kind of like them here, but again, maybe some feedback there. Should these be in a separate file or not? I feel like they probably should just stay here, as this is going to be like the Mongo connection class, but you could break it out and have a Mongo connection constants file, and then you could have your connection class, which is just your methods and what they're doing. So it's really kind of just a design choice. I don't think there's a right or wrong way there. Let's see. Create a data class to hold our BSON document. So this is our data that we're sending up currently, and we need a data structure to represent all of the fields that we need within our map data that we're pushing to the cloud. So whether it's going to have the map name, the image data, the timestamp, whatever credentials we need, or whatever, not credentials, whatever properties we want within that document, we'll need to put that in its own data structure. So, oh yeah, so stars, I had labeled that. So stars could be like reviews almost, or how popular the map is. Is it good? Or maybe they're difficulty stars. Is the map extremely difficult? Is it not so difficult? And that might give other users an indication of how, if they want to play that map or if they want to use it. Batch uploader for multiple files. This is something I had an idea for. So if someone wants to upload 3 or 4 files, instead of running through the process 3 or 4 times, we could build a batch uploader that could just grab all of them and then iterate over them and push them up. And then I've talked about the database wipe interval before too. As far as like the consistency within the methods, everything, all the for loops and if statements here and things like that, they look good. I'm pretty happy with variable names. Again, we definitely need code comments here. We need to break out some of these pieces. This has got to be in its own data structure, like I said. We got to work on this. That shouldn't be hard coded. That should be in its own utility class. So there's definitely some work to be done here. But this is just kind of a rough draft of we've got the functionality. We're able to connect to it. We're able to see it work. And it gives me a good baseline for moving forward with the enhancements. But I'm excited to continue to work on this. It's a pretty cool feature. So, all right, I think that should do it. And that'll wrap up all 3 of my enhancements here. And we'll get these up to our portfolio and things should be good. All right, thank you.